Hello everyone, welcome to ECJ Square T channel. Vanakkam, Namaskar, Swagatam. Today we are going to see about IoT communication APIs. That means application program interface. So how this communication program, application program interface, how using models it will be accessing. So this for in order to accomplish the APIs. So communication APIs. So what all the models, protocols are present, that we will see it in today's video. So the previous video which has communication models, if you didn't see, please do subscribe to my channel and please do watch all the videos regarding IoT. Okay, we'll go into today's video. So IoT communication application interface. So communication application interface. So what it does, like there are two types of communication API. One is REST-based communication and WebSocket-based communication. Okay, REST-based and WebSocket-based. So if you see REST-based communication API, see the HTTP client is there. So HTTP packet is there and HTTP server is there, resources will there. If our client want to open one page, so what it does, it gives a request, that means it sends one data, it gets or posts or puts or deletes. So these are the HTTP comments which are present in order to accomplish the communication. So that packet will be given to the server. So now the server, what it does, it authorizes. So it sees the HTTP packet and it verifies whether what information it needs. So where is that information is present. Then after authentication, this HTTP server, what it does means, it again like it retrieves the data from the resources and give that to the client as a HTTP packet. Okay, so this is the architecture. This is the architecture of REST-based communication. So REST-based communication, REST means representational state transfer. So it is a set of architectural principles by which you can design web services and web APIs that focuses on a system resources and how resources states are addressed and transferred. Okay, REST APIs follows the request response communication model, which I have discussed in the previous video. If you didn't watch that video, please do watch that video and do subscribe to my channel for further notifications of the videos which I'm going to post. So the REST architectural constraint apply to the components, connectors, and data elements within a distributed hypermedia system. So I've shown you like that is about the REST. So the REST architectural constraints are client server, stateless, cacheable, layered system, user interface, code on demand. These are all REST architectural constraints. So what are the REST architectural constraints present? That is client server, stateless, cacheable, layered system, user interface, code on demand. So this is about the architectural of REST-based communication. So we will see one by one what is client server. So the principle behind the client server constraint is the separation of concern. So for example, if you take, client should not be concerned with the storage of data, which is a concern of the server. So similarly, the server should not be concerned about the user interface, which is the concern of the client. So separation allows client and server to be independent, developed and updated. So this is about client server. When we say that REST-based communication is a stateless, then each request from the client to server must contain all the information necessary to understand the request and cannot take advantage of any stored context on the server. Okay, so the session state is kept entirely on the client. So when I say that REST based communication is cacheable, so cacheable constraint requires that the data within a response to a request be implicitly or explicitly labeled as catchable or uncatchable. If a response is catchable, then a client catchy is given the right to use that response data for later. So a later equivalent request. So caching can partially or completely eliminate some interactions and improve efficiency and scalability. So when I say a request response model, that is REST, is a layered system. That means a layered system constrains the behavior of components such that each component cannot see beyond the immediate layer with which they are interacting. So for example, a client cannot tell whether it is connected directly to the end server or to an intermediary along the way. So system scalability can be improved by allowing intermediaries to respond to requests instead of the end server. So without the client having to do anything different. So uniform interface, that means uniform interface constraint requires that the method of communication between a client and a server must be uniform. So resources are identified in the request and are themselves separate from the representations of the resource, so that are written to the client. So when a client holds a representation of a resource, it has all the information required to update or delete the resource. So each message includes enough information to describe how to process the message. So when I say a code on demand, servers can provide executable code or scripts for clients to execute in their context. So this constraint is the only one that is optional. So a RESTful web service is a web API implemented using HTTP and REST principles. Okay, so RESTful web service is a collection of resources which are represented by URIs. So universal resource identifiers. So REST. So when I say it is as REST, so a REST is a collection of resources. So URIs will be present, there we will be having all these things. So RESTful web API has a base URI. So the client sends requests to these URIs using the method defined by the HTTP protocol. Okay, so IP for small object aliens. So all those things using that, the request will be sent to the server, and from the server, what it does, it retrieves the data from that URI, like it retrieves the data from that address and gives that information to the client using the HTTP protocol. Okay, so the next communication is what a request response model used by REST. So this is the way. So the client, it gives request to the server, and then it gives a response that it has accepted, and now again this will get like get, put, update or delete using those with the payload. That means with the data that client will be giving a request to the server. When the server responds, like accepted that request, it gives a response to the client. So this is request response model used by REST. So REST follows request response communication model. So the next communication API is WebSocket based communication APIs. So WebSocket APIs allow bidirectional full duplex communication between clients and servers. So WebSocket APIs follow the exclusive pair communication model. Unlike request response APIs such as REST, the WebSocket AI allows full duplex communication and do not require a new connection to be set up for each message to be sent. So WebSocket communication begins with a connection setup request sent by this client to the server. So this request is sent over HTTP and the server interprets it as an upgrade request. So if the server supports WebSocket protocol, the server responds to the WebSocket handshake response. After the connection is set up, the client and the server can send data or message to each other in full duplex mode. So WebSocket APIs reduce the network traffic and latency as there is no overhead for connection setup and termination requests. So for each message. So WebSocket is suitable for IoT applications that have low latency and high throughput requirements. So wherever we want like battery handheld devices will be there now. So there in that application we can use with WebSockets. Okay. So structural, for example, structural health monitoring systems use WSNs to monitor the health of structures by collecting vibrations data from sensor nodes deployed at various points in the structure. So WSNs are enabled by wireless communication protocols such as Zigbee, so which has a power specifications. So the power of WSN lies in their ability to deploy a large number of low cost and low power sensing nodes for continuous monitoring of environment and physical conditions. So WSNs are self-organizing networks. So for this kind of communication, we can use WebSocket communication. So this is the WebSocket protocol. So client gives a request for setup to the server. As this WebSocket protocols follows the exclusive pair communication protocol, so it requires setup connections or setup configuration it requires. So it gives the request for setup, and when the server, so it is like initial handshake. Okay, after requesting, after requesting, once it gets a response from the server, it starts sending data frame. So it is a bi-directional communication. It can send, and the server also can send data, like it is like chatting from. We can also give a message to our friend. Friend also can give the message to us at a time. So when the communication is completed, we can request for a close. So connection close request can be given. So this is about communication APIs present in IoT. So I'll meet you in the next video. Bye.